Okay, hello YouTube. My name is Sheridan. I'm the circuitry artist, and I am doing something today that is not exactly circuitry, but it is something that I did learn in college, and I figured, I spent a bunch of money to learn this, might as well use it. So, recently I've decided to take on what I think is, a fairly light stretch of a project, which is to make, as you can see here, an automatic irrigation system for a small-scale garden, written for the Uno board, but you can probably use the Nano as well, or the Micro. I don't actually know what they call it. Somebody should fill me in on that, or I can probably just check the Arduino website like a competent person would. So the purpose of this code is to run a circuit that maintains a specific hydration level for soil bodies by turning on a pump and opening a specific valve for that specific zone. So when moisture sensors fall below a calibratable level of conductivity, it will also flash a warning light when water tank is empty. So basically this works like a thermostat, in that if your temperature is below a set point, it will turn on your heater. But the difference being is that if your moisture level is below a set point, then it will turn on a pump to supply moisture. So it's basically running 4 different feedback loops for each body of soil. So here are our soil sensors. They're all connected to your A0 through A3. Valve signal outputs 2 through 5. They're digital outputs. These are your calibration buttons. So the way that the calibration is going to work is that in the moment that the soil is just the right amount of saturation, when the soil has the right amount of saturation, the user is supposed to press the button, and then it will cause the set point to be made equal to the current saturation value. So that way I don't have to take a soil probe, dip it in a sample of soil, and try to do a bunch of guesswork on the right constant comparison value. Plus there's tons of variables that can affect the way a moisture sensor reads a sample of soil, such as the soil composition itself, or how well it absorbs water. So this way I don't actually have to do that kind of testing. It just, whenever it is the way that you like it, you press the button and it will keep it the way that you like it. You'll see later in the code. So these are four buttons for each 4 zones to set the calibration level. So these are the core components. We have a tank switch, a pump, a tank LED, and a sensor net relay. This is there because I only want the sensors to come on every 5 minutes, so that the sensors aren't continuously running. Because with a capacitive sensor, I'm not using conductive sensors, but because they'll corrode and they leave trash in your soil. So the idea with the capacitive sensor is that it'll run a 555 through the capacitor that is laid out on the tab that's in the soil, and the capacitance changes, and then that makes an analog voltage output. You get the idea. But the thing is, I don't want those sensors. They're active sensors, and I don't want them to be running all the time. So this is to prolong the life of the sensor and to prevent corrosion. There's just a bunch of benefits to only turning them on a certain amount of time, and I definitely don't need them to be running all the time. I don't really need to be exactly that precise in how much water gets to the soil. I just need it to maintain a fairly close level of moisture. So I've included some wiring diagrams. I'll try to explain those the best I can because I don't like the idea of having to look somewhere else for the wiring diagram other than the code. So that way, if someone wants to rebuild this, the wiring diagram is included in the code, and I don't have to like send them additional files that I drew in MS Paint. So, or or scratched on a piece of paper and then take a photo of the paper and then send that. Yeah, no, I don't want to do that. So I've included the wiring diagram in the code as comments. So the way this works is that these lines are actually 4 different instances of the same circuit. So you will have 4 soil probes, so you will need to make 4 of this line. There are 4 calibration buttons, so there will need to be 4 of this line. And so I'll run through some of the symbolism here. Anytime there is a rounded parentheses, that just means a point connection. If you see a number in the rounded parentheses, that means it's a pin connection. So what's going on here is that there's a 5-volt relay, or there's a 5-volt source. It's going to run through a normally open relay on the relay PCB, the 5th one to be exact, and it's going to be outputted to point A, and from point A the circuit will be split 4 ways into the 4 soil probes. So this is the relay that turns on the soil probe sensors. This is a 100k ohm resistor. This is your ground connection, and so this means that in the 4 instances of this circuit, one of them will be connected to A0, A1, A2, and A3 in each instance of the circuit. So, and there will be 4 soil probes. So what this can be read as is 4 lines, 4 different lines. One of them has A0, the next one has A1, the next line has A2, the next line has A3. You kind of get the idea. Here's our tank float switch circuit. It is a basic pull-up circuit. I try to make things sort of correlational so that when the tank is high, the float switch is on. That is a logical high. You know, it's kind of mnemonic like that. This line is just a basic LED that's run to ground with a 220 ohm resistor. This is the Uno board to the relay PCB in 5. You kind of get the idea. It's kind of self-explanatory. Here's the line that runs the pump, goes through a relay, and it's powered by the 12-volt source. Relay 6 to the pump and then to ground. I hope I've explained it well enough, and avoided over-explaining it. So, our internal variables. These are all the variables that are not associated with a specific pin, and so they don't really show up outside of the board. So here's all our level settings. This is our desired saturation levels. Here is the variables that record the saturation levels in the soil. So when a sensor is red, when sensor A is red, it will go into the current. It will go into sat A. These are the variables that will read the calibration buttons. This is the variable for reading the tank state. This is a 5-minute interval. You can't use the number 5 and then the MIN. You can't, because there's some sort of pre-written library that with that variable, so you can't use it. So you have to type out the word 5. And so 300,000 milliseconds is equivalent to 5 minutes. And so this is the variable for timing the length between each reading of the sensors, because the relay is only going to turn on every 5 minutes to power the sensors up so that they can be read accurately. This variable is for marking down that the last time that the sensors were read. You'll see how that works later in the code. So yeah, running the sensors only every 5 minutes is also good if you're going to use your standard conductive soil probes, because you definitely absolutely do not want those on all the time and have that electrolysis running 100% of the time. So here we get to our setup. Here are all our pin assignments. They're pretty self-explanatory. Here's where we set the set levels greater than any possible sensor readings. The reason I do this is the reason that I'm running. Sorry. The reason that I'm setting each level at maximum initially is because in the event that there is a specific body of in the event that any one of these A, B, C, or D zones ends up not being used, and they only use 3 zones, that particular soil sensor is going to return a value less than 1024, which is actually going to trigger them on. I think I need to set these to 0. Yeah. Hold on. I may have made a mistake. Okay, yes, I did make a mistake. They all actually need to be set to 0 initially, so that the returned value of any unconnected or any unconnected soil sensor or any soil sensor that is connected but not dipped in soil will always return a value greater than 0, and that will cause the that particular valve and zone to not turn on. And so because there's no reason for it to. So here is a specific measured amount of delay. You'll see why I include this later in the code. It's to prevent, well, I'll just read the comments here. I have to wait 5.001 seconds before starting loop so that the millisecond rollover routine isn't triggered by an initial runtime of less than 5 seconds. You'll see why I include that later. It'll make sense. So the first step is to run our calibration sequence for any buttons that will be pressed down. So before anything can get turned on, one of these buttons has to be pressed to calibrate the zone. Otherwise it will not turn on, because the set level will always be less. The reading will always be greater, making the Arduino think that it's plenty saturated and it doesn't need to turn on any zones. So if we want to calibrate zone A, we push calibration button A so that calibration A equals high. So when that happens, it will turn on the sensor network. It will wait 1.5 seconds so that if there's any fluctuations during that period of the relay turning on and then the sensors turning on, it's not going to immediately read any sort of bouncing that may occur as the sensors turn on. It's going to wait 1.5 seconds for any bouncing to settle. And once the delay has passed, it will set the desired level of moisture equal to the current level of moisture. So you always you want to make sure when you press the buttons, the current moisture level in that soil body is the desired moisture level. If it's a little less, then you add more water. If it's a little more, then you wait for the water to evaporate. It's kind of a simple process. So then once it's recorded, it'll turn off the sensor net and delay for a second just to wait for your... It's to wait to let go of the button in case it got held down. And it can do that for all 4 bodies of soil. Here we get to our tank reading. First step is to check the tank level, flashlight if too low, and turn off the pump. Pretty self-explanatory. Here we turn off the pump and it'll run this routine continuously as it loops around if the pump happens to be low. Because just about every single command except the calibration readings is an if statement. Everything is contained in if statements. So that if the tank is, I can say in all the other if statements that if the tank is anything other than low, to run none of the other commands. You can see that here. So here's what happens every 5 minutes. Every 5 minutes, this will record the current millisecond time as a single variable. So if the current milliseconds recorded in the Arduino are greater than the last check time plus 5 minutes, so 5 minutes after the last check. I actually need to set this as a initial variable, come to think of it, because I think it is not assigned. Yeah. I think I need to set last check equal to 0. Yeah. So I need to go up here. Okay, so I went back up to my global variables and I assigned last check as 0 to start with, just to eliminate any kind of weird behavior. So what this says, if it has been 5 minutes since the last time the sensors were checked, it basically checks the sensors again, and it has to turn on the turn on the sensor network, wait for the readings to settle, record the readings, and the variables that get recorded here will affect the if statements for turning on the valves and the pump later in the code. Yes. Okay. So this is what I was talking about with the 5001 millisecond delay. So every 50 days, the millisecond value in the Arduino will roll over to 0 because a milliseconds is an unsigned long, which I don't remember the exact number, but every millisecond it will add 1 to the value of the unsigned long variable. So eventually it reaches a maximum number of digits, and when that happens, it will roll over to 0. And when that happens, what that means is the last check plus 5 minutes will always be greater than the milliseconds, because the last check is made equal to the milliseconds every 5 minutes. And if this code isn't there, this code ensures that the last check variable rolls over in conjunction with the millisecond variable. So that way we don't run out of millisecond digits, so that the last check number of digits doesn't exceed the millisecond number of digits. I think I explained that right. Anyways, that only happens every 50 days, so if this part of the code doesn't really work, I can just hit the reset button. But I prefer not to, because the whole point of this is to not have to look at my garden or actually, attend to my garden when it needs water. Where was I? Oh, yes. So, I'll talk about this. I'm sort of running the first time this loop runs, and so I'll get to this code on the second run through. I'm gonna run through the loop twice just to show you how the loop flows and how the previous loop will affect the next loop. So I'll skip this for now because as the pump so far has not been turned on in the code. So I'm gonna walk through if the pump had turned on last loop. I'll show you what happens because it affects more than just this code. So here is where our basic fundamental feedback comparison is made for all 4 zones. So if saturation A is if saturation A is less than the set level, we're going to turn on the pump and we're going to turn on valve A. Otherwise, if it is, in other words, if this condition is not met, we're going to turn off the valve. And we're going to do the same thing for all 4 zones. Now, if we get down here and all the valves have been turned off, then we're going to turn the pump off as well, and we're going to turn off the sensor net as well. And then we're going to reset our sensor checking timer. Now, let's say, for instance, that that our pump got turned on because this condition was met. Our saturation in zone C was less than our desired set level. We'll turn the pump on and we'll turn on valve C. That means valve C will be high, this code will not run, the pump will not turn off, and the sensors will stay on. And we will not reset our check timer. Sorry, my throat's getting really dry. So then we're going to run through the code again with the pump on. And so we'll skip our calibrations because we'll assume everything's already been calibrated to the desired level. We'll check our tank to see if it's high. So we'll say that the tank is fine. The last check is not greater than 5 minutes, since we just barely turned on the pump. We're not undergoing a millisecond rollover. So if the pump equals high, which it was written so in the last loop, we're going to take another reading of the sensors. And so we're going to go back, since none of the other sorry, it's late at night and I'm having trouble focusing because it took me like 3 days to write this code. Actually took me longer with all of the drafts that I made. So the pump was turned on in the last loop, so we will run this section of code and read all the sensors again. And let's say this time around, when we get back, since none of the other valves were turned on, we'll skip all this. We'll go back to C, since that was our currently open valve. So let's say this time around when we run the loop, zone C surpassed its set level. So now zone C is greater than, this condition is not met because our saturation in C is greater than our set level. So in that case, we will turn the valve off. Now we will check to see if all the valves are off, and since zone C just turned off, now all of them are off. At this point, we turn the pump off, and we turn the sensor network off, and then we reset our interval timer for checking the code. And so this way the pump will be continuously turned on until for every loop until the saturation is above our set level, at which point it will turn off the valve, and then when all the valves are turned off, it will turn off the pump and the sensors. Okay. So, if you have any questions about the code, or any criticisms, or would like to complain about how much simpler I could have made this code, yeah, definitely leave a comment. I will try to include either a link to this code or actually the code itself in the comments, so that if you want to build this whole system along with me, you're certainly welcome to do so, since this is all open source. If you want access to the parts list, I will leave a link to my Tumblr blog. Actually, I'll just post the link to my parts list. With the parts list, there are a bunch of parts that you don't need included in there. If you go to the parts list, there will be a specific kit that includes 4 pumps that you can actually use on the valve outputs of this particular circuit. Actually gonna see if I can no, I can't seem to yeah, no, I closed the window. I was going to show you my parts list, but there is a specific kit that you can buy that includes 4 soil sensors, a bunch of tubing. It includes 4 actual pumps, not just valves. I'm going to try to stick to valves and use 1 pump. The only thing that it really doesn't include is LEDs and the relay board. Actually, no. It actually does include a 4 relay board. This project, however, requires 6 relays, so you can either buy an additional 2-channel relay board, or you can just buy a 6 relay module. I just simply recommend getting that kit to get started, and then if you need additional parts for whatever accessories, then you can do that. But definitely start with the kit, because it includes the right kind of sensors that you should be using, not the crappy, cheapy conductive sensors. I'm trying to think if there's anything else I want to say. Thinking. Okay, I just realized an error that I made in my code. A little tiny error. So, I have added this little bit here because I realized that as the code is running, when all of the conditions have been met, all the valves will be written low, because all the valves will be written low constantly, so long as if the pump is idling. Anyway, so I only wanted to run this section of code after the pump had been on. So I added this section. If the pump is high, is currently written high, and all the valves are low, then turn the pump off. Because I also have my last check reset, and I realized that every single time that it runs through this code, all the valves are going to be low, and it's going to reset my last check every single time. So to avoid that, I have to include the pump being written high as a condition of this section of code. So, yeah. I think that's all I have. It's late at night. I'm gonna go to bed. Good night.